Yeah, and so the vector from B to A?
Is it -4, -2?
That's it. So that's A and that's B. So if you had a vector between these two and you called that vector A, I'll just draw a little vector. If that vector, and you have to draw an arrow showing which direction it's going in. So if that was the vector A, then because this one was -4, -2, basically going against the arrow would be -A.
Okay.
So B to A would be -A, and A to B is A.
Okay.
Let's not worry about these. What would be part A for this one?
Would it be 5, 6?
Yes. And so it's basically 2 across plus 3 across is 5 across. 5 up plus 1 up is 6 up, and so on. It's so simple. We don't need to do this. I'll just get you to the proper ones. Okay, what is the missing vector here?
Yeah, I'm not sure.
So if you start, I'll call these points X, Y, and Z.
Okay.
If you go from X to Z in terms of A and B, so you can only go along lines that have A or B.
Okay.
X to Z is X to Y plus Y to Z because you don't have any vector on X to Z. What is X to Y?
Is it A, B?
Yeah, so A plus B.
Okay.
Yeah. What is the missing vector in this one?
Is it P? Is it I'm not sure.
Well, if this one is P plus Q, then going this way.
Oh, is it Q?
Yeah. And this last one?
Is it W?
We already have W.
Oh, sorry, U. Sorry.
So it would be U. Yes. This is the little thing. Okay, exam question. What is the vector A to B in terms of A and B?
Is it A plus O?
What's that?
A plus O.
So it's A to O, and then O to B.
Okay. Yeah.
So what are those vectors?
I'm not sure.
From A to O.
Is it A plus O?
So in terms of little a and little b, what is the vector O to B?
I'm not sure.
B.
Okay.
So let me go back a second. So this one is the vector 4, 2, yeah?
Yeah.
We just say let 4, 2 be equal to A. And so you just you can just replace the numbers with some letter. It just makes it a bit easier. And so instead of having to do -4 and -2, you can just say going the other way is -A.
Okay.
If you went double that length, it would be 2A. Triple the length, 3A.
Okay.
So it's just replacing the numbers with the letters. So for this one, so maybe B is 4, 2, maybe it's 5, 7, you know, who knows. But O to B, they're just calling it B.
Okay.
And so O to B is B. What would be A to O?
Would it just be A?
So O to A is A. A to O is going against the arrow. So that would be?
-A.
Yeah. That's all there is to it. -A plus B. There you go. Okay, so this one, S to Q.
Is it B? No, sorry, N.
In terms of A and B.
A and B. Would it be plus A?
Yeah.
Okay. I'm not. Yeah, I'm lost again.
So you have to start at S,
Yeah.
you have to reach Q, and you can only go along A and B lines.
Okay, so would it be minus B plus A?
That's all there is to it.
Okay.
Minus B plus A. They wrote it as A minus B, same thing. Okay, this one, A to B.
Okay, would it be minus A plus B?
You've got it. Okay, this one.
Would it be minus B plus A?
Yep. Okay, this one.
Would it be minus 6A plus 6B? And for E to F, would that be plus 6A
That's
minus
it.
B?
No. From E to F, just looking at the diagram, what vector is the same length and same direction as E to F?
6A.
Yep. And so it's just 6A.
Okay.
So vector is just like if that was, let's say, minus 3, 4, then this is also minus 3, 4. And,
Okay.
so those two are the same vector. Okay, how about this?
Would that be my plus A plus B?
Yeah, A plus B. And part 2.
Would that be minus A plus 3B?
From P to R, yes, minus A plus 3B. And you can see if you went this way, you reach a dead end. So you have to go find the other route. Minus A plus B, minus A plus 3B, and the other one was just A plus B. Yeah, that's it. Okay, how about this?
Would you do minus 2A plus 4B?
Minus 2A plus 4B. Yep. This one.
Would that be minus 3A plus 6B?
Yep.
Would that be plus 2A? Or would it be plus 3A plus B?
Yep. 3A plus B.
Would that be minus 3B plus A?
Okay, I can find displacement vectors in terms of lowercase letter vectors.
3/4.
Yeah, those are all exam questions anyway. That's what they look like. If A is 4 right, 3 up, then 2A is 8 right and 6 up. Minus 3A, you just times them both by minus 3. 2A, you just times them both by 2. Just double it. So for this one, what is 2P?
Is it 2/5?
So P is 2/5.
Would it be 10? No, sorry, 4/10.
Yep. So that is 4, 10. And how about D? Yeah.
Is it minus 15, 10?
Minus 15, 10. Yep. So it's 5 times as long and the opposite direction. What would be C?
Okay, would it be 6 and 0 plus
this is 2T.
2T? So that would be 4, 6, add 3, 0.
Hold on. 2 times minus 2?
Minus 1. Oh, sorry.
Okay, yeah, minus 1.
And 3. But hold on, I forgot to times 2, so it'd be minus 6.
Slow down. It's 2T. What is 2T?
So it'd be minus 4, 6.
Yeah.
So that would be minus 1, 6.
Yeah. It's the first time you just said 4 instead of minus 4. Okay. This one, part A.
A to C. Would that be P is the midpoint AC. So would it be 2B?
Yep. Okay, this one.
C to A. Would that be
And O is the midpoint of this
Uh-huh.
trapezium.
So would it be 2A plus 2A?
Yep.
And BC, would that be would it be plus B?
No.
Oh, minus B minus A.
Well done. Yeah, so this one here is A plus A, and so when you go against it, it's minus A.
Okay.
Okay, so these are your previous answers written as best I can. Do part B.
Express XZ in terms so would that be I'm not sure.
E to X. What is E to D?
Oh wait, so E to D is then D to C to half. So would C to X be plus 3A?
C to X. So C to X would be 3A, yep.
And E to F would be 6A, so it'd be the same. So D to C would be 6B.
Yep.
And then A to B is 6B minus 6A. So would that just be is it just 6B minus 6A?
Mm-hmm.
Same size. So that would be minus 6B minus 3A.
So 6B plus 6B minus 6A minus plus 3A.
6B plus so 6B plus 6B, that's 12B. Minus 6A plus 3, that's minus 3A.
Well done. That's it. So vectors are just movements, like 4 right, 3 up. And so you just look at what is the same vector as that. So E to D was the same as A to B, which was your previous answer. D to C, you saw that was 6B. And C to X would be 3X. It's half of
that.
Okay. This one, no, that's higher. This one, no. This one, it's not really representative. Like you can see there's a million questions that look like the ones we did, and then there's just this one weird one. It's not worth your time. Okay, this one.
3/4 again.
Okay. Let's see this one. All right, let's try this.
So would that be
No, let's leave that for a moment. Yeah, as a ratio, so I should really change it from ratio to fraction. Okay, let's just try this one, see how we do. Your previous answer was A to B is B minus A.
A to B is B minus A, so, and we want to go to O to B. So would it be so would it be B minus A minus B again?
So how do you get from O to P?
So would you go plus A and then
yeah.
I'm not sure about the A to B bit because P is like 2/3 up the way.
It's not 2/3. What would these ratios be as a fraction?
1/4, 1/4, of course.
So that one's a quarter, and so the other one?
3/4.
Yeah. So O to P is O to A plus A to P. You said O to A is A, and so A to P.
Would it be 3/4? Three
Yeah.
quarters.
That's 3/4 of A to B.
Okay.
What is A to B?
A to B. A to B is minus B. Minus A.
B minus A.
Oh, B minus A. Sorry.
Okay. Expand and simplify.
Okay. So would it be? Would the A and minus A cancel each other out?
Expand first. Bidmus, brackets first.
Oh, B minus A. Oh, is that just still B? I'm not sure.
Expand.
Okay. So would it be 3/4 BA?
No. 3/4 times B, and then 3/4 times minus A.
So that'd be 3/4 minus A, or minus 3/4 A.
Expand these brackets.
3B minus 3A.
There you go. And so same thing for this one.
So it'd be 3/4 B minus 3/4 A.
That's all it is. And fully simplify.
So would it be 3/4 plus 3/4 B?
So you've got 3/4 B.
Okay.
You have 1A, and you have minus 3/4 A.
I'm not sure.
What if it was A minus 0.75A?
I'm still not sure.
What is 1 minus 0.75?
1 minus 0.75, 0.25.
Yeah. So you could say plus 0.25A. And what is 0.25 as a fraction?
0.25 as a fraction. Is that one quarter?
Yeah. And so basically, 1 is the same as 4/4. 4/4 take away 3/4, 1/4. 3/4 B plus 1/4 A. So it looks very different from what you're used to, but it follows all the same rules. So they did that. Okay, let's try it.
Okay, so A to B is 4B minus 2A, and we want to go to O to N. So B O to N would be a plus 8B. O to B would be plus 4B, I think.
You could do that. So you could go O to B and then B to N, which is part of B to A.
Or you could you go O to A then A to B?
And it's better to do it that way because we already have A to B.
Okay.
So it's just going to be less work. So it's O to N plus A, sorry, O to A plus A to N. Okay, go on.
So with O to A be would it be a fraction?
From O to A?
Yeah. So would it be like
No. What is the vector from O to A?
2A?
Yep.
Plus 2A.
And then how do we do A to N?
A to N. Would it be 3/4 again?
Yeah. Of what?
Of I'm not sure.
A to N is 3/4 of what?
I'm not not sure. 4b minus 2a?
Yeah, basically it's 3/4 of a to b.
Okay.
So a to n is 3/4 of a to b, and previously we said a to b is 4b minus 2a. So we're kind of putting it into that b and a. Okay, try this.
Okay, so would it be 2a plus 3a, 3/4 of 4b?
And what is 3/4 times 4?
3/4 times 4, that's, is it, I'm not sure. Is it 12 over 4?
Yeah, what is 12 divided by 4?
12 divided by 4, that's 3.
That's it. So that's 3b.
And then 3/4 times 2 over 1, that's 6 over 4. And then divide that, that's 2 point
No,
6,
just simplify it.
1.5.
Sure. So that is minus 1.5a.
So would it be 0.5a plus 3b?
Yeah. 3b plus 0.5a. So common thing to get from there, you use your previous answer. A to b is this, a to n is 3/4 of that, and so you just times it by 3/4.
Okay.
Okay, how about this one?
O to x. So would go O to a, and that's just plus a.
Yeah.
So and then a to x is 1 over 5 out of b minus a.
Yeah.
So it would be a plus 1/5 b, 1/5 of b.
Yep.
Minus 1/5 of a.
Yep.
So would it be oh, I'm not sure. A minus 1/5 of a.
1a is the same as 5/5.
Okay, so would it be 4 minus 4/5?
Mm-hmm. Oh wait, not minus.
Not minus.
Yeah.
Oh, so 4/5 a plus 1/5 of b.
That's it. So yeah, 5/5 take away 1/5 is 4/5. 4/5 a plus 1/5 b. Okay, how about this?
Okay, so we want to go enter R. So would you do enter R? I'm not sure. Oh wait. Oh no.
And what's quite common in these vectors, as we're seeing, is that it helps to use your previous answer.
Okay. So SQ is so S to N is 3/5 of B minus A.
Mm-hmm.
So
you have to go from N to R.
So would it be would it be plus 3/5 of B minus A?
Okay.
And then plus B, because P to S looks the same as Q to R.
Well done. And they told us that S to N is to N to Q, 3 is to 2. So this bit is 3, this bit is 2. So what fraction is this bit, N to Q?
Is it 2/5?
Yeah, you said 3/5 first time. Okay, go on.
Okay. So would it be 2/5 of B minus 2/5 of A
Mm-hmm.
plus B?
Yeah.
So would it be 3/5 of A? No, 3/5 of B. Sorry.
2/5 plus B. There's
Oh,
no.
2/5 plus A. So that would be 2/5 plus. So that would be. Would it be 7/5?
Yep.
7/5 of B minus 2/5 of A.
Well done. 2/5 A plus 3/5 B. We went wrong somewhere.
I think we're adding, then we have to get the same denominator. I'm not actually no, they already got the same denominator.
No. What did we do wrong here? Express n to r. N to q plus q to r. Let's see. So n to r. We're starting at n. We have to get to r. That's the same as n to q plus q to r. So from n to q. That is 2/5 of b minus a. 2/5 of b minus 2/5 of a. S to q. It was my mistake, sorry. The previous answer was minus b plus a, not minus a plus b.
Oh, okay.
Yeah, my mistake. The previous answer should have been minus b plus a. We did everything correct. Okay, how about this?
O to N in terms of A. So would you do to O to B is plus B?
Okay.
And is then it be one from B to N? Would it be 1/3 of it'd be 1/3. I don't know what of. Is it just 1/3?
1/3 of what?
Uh,
You don't need any. Just in terms of the big letters.
or would it be 1/3 of? I'm not sure.
So it's 1/3 of that total line.
Yeah. So would it
What
be?
can you call that total line?
I'm not sure.
You are.
Is it B to A?
But yeah. Okay.
So would it just be B plus 1/3 at BA?
Now, what is BA in terms of little a and little b?
Is it A plus B?
So start at B, go to A.
Oh, okay. So it's minus B plus A.
Yeah.
So 1/3 of minus B. Oh no, B plus 1/3 of minus B. 1/3 of minus B.
What is that?
That's. Wait, say again. So plus 1/3 of minus B.
Okay.
And plus 1/3 of A.
So plus 1/3 A.
Oh, would it be plus minus 1/3 of B?
Yeah. And so final answer.
So would it be 2/3 of B plus 1/3 of A?
Yeah. So the difference with this question was there was no previous answer. This was part A of the question. So there was no previous answer to use. You just had to actually get it all in one go. So usually we could use our previous answer for BA. For this one, you had to actually find BA. So it's just extra stuff. And still a 3 marker. You'd think it'd be worth more. Okay, I can express ratio vectors for 3 mark questions.
Half.
So Vectors are as tough as they get. Let's see this one. So now there we go. Vectors 2. So I recognize these. Okay, so that was warm up. All of that. Multiplying vectors. Okay, so that's what they call vectors 2. And then vectors 1. Hey, is that here 2 vectors? Resultants. Okay, starter.
Okay, so would the first one be 36?
Yeah.
And then this one would be 16.
Well done.
So 2 times 2, that's 4, 60. 16.
Mm-hmm.
And that's the next one is 1.
Do you already know how to do this top one?
Okay, so how can we simplify 2 5s? Will that be 2 times 2 times 2 times 2 times 2? Will it be 2 times 2 5 times?
Sure.
Uh,
Let's try the one up here.
okay. Would it be 2 7 to the power of 7?
Yes, so this one up here, x to the 7. What is the quick way of going from having 3 and 4 to just 7?
We just add them together.
Yes, and so the rule for multiplying indices is you add the powers, copy the base, add the powers. So this one?
Would it be 2 to the power of 11?
Yeah. Okay, top left.
5 to the power of 10.
Middle.
X to the power of 6.
And top right.
2 to the power 2 to the power of 6.
Yes. Multiply indices.
Tick.
Okay, how about this one? Let's do the one down here.
Would it be 5x to the power of 9?
So x to the 9 is correct because that's the rule for multiplying indices.
Would
The other two are just normal numbers.
Would it be 6?
Yeah, and so indices often creates a mix of normal multiplying and following the index rule of adding
Okay.
the powers, which is how you multiply them. Okay, top one.
Would it be 10x to the power of 5 with y to the power of 9?
Yeah, and what's the number in front?
20x.
Yeah. Let's try top right.
Okay.
Or hold on. Let me. I put it in the wrong place. What would you get here?
Would it be?
Oh, no. Let's just. I really need to swap those around. If you just have something by itself, like x, that is the same as x to the power of what?
Is it x to the power of 1?
Yeah. Okay, so top right.
Would it be 10a to the power of 5 and b to the power of 4?
Yes, well done. And bottom one.
Would it be 28 to the power of 24a to the power of 4 and b to the power of 3?
Yeah.
No, minus 3. Oh no, sorry, just 3.
That's it. I can multiply indices with 3 terms.
Yeah, tick.
Any idea how you divide indices?
Will you just take away the indices?
Yep.
Would it be 5 to the power of 3?
Yes. And so top left,
7 to the power of 3.
top middle,
H to the power of 5.
And top right.
Is it 7G?
No.
Oh, is it just? Oh, is it 6 to the power of 6?
So it's to the power of 6.
6. Is it just 7G, or is it just G?
No.
I'm not sure.
Was this one? So this wasn't 0. You don't take away the 7s. You don't divide the 7s. You copy the base and you subtract the powers.
I'm still confused.
So 7 stays the same.
Okay.
H stays the same.
So this is it G minus 7 to the power of?
Yeah. So that stays the same as well.
Okay.
Divide indices.
Tick.
You don't need to do that.
Yeah.
How about this?
Is it does it stay the same? So it'd be no, wouldn't it be 4A to the power of 3?
Well done. How about C?
C. Would that be 3x to the power of 2?
Yeah. How about this?
3x to the power of 2 and y to the power of 4.
Let's try top left.
Okay. So would that be 5a to the power of 4 to the power to b to the power of what? 3.
Well done. Top right.
So would it be 2m to the power of minus 2?
Yeah.
And t to the power of 4.
Well done. And bottom right.
Would it be 3a to the power of minus 1?
Not minus 1.
1. Oh no, sorry, minus 4. Sorry.
Yeah.
And f to the power of 6.
Yeah. I can divide indices with 3 terms.
Yeah. Tick, yeah.
Let's just try bottom left.
So would it be t? It would first start off with t to the power of 15 divided by t 6.
What is the rule for multiplying indices?
They add together. So would it be t to the power of 8 divided by t to the power of 6, and that would equal t to the power of 2.
Yeah. Top right.
Okay. So would it be to start off? It would be p to the power of minus 1 divided by p to the power of 2.
No. What's the top bit?
I said it was minus 1, and I thought we're dividing. So it'd be p minus 1. Is it p to the power 1?
What is the rule? How did you get this one?
It stays the same. So you take away
Slow down. Where does the 8 come from?
the 8 comes from the 3 and the 5, adding them together.
Alright.
Oh yeah. So would it be p to the power of 7
Yes.
divided by p to the power of 2 equals p to the power of 5.
That's it. Top left.
Okay. So would it be n to the power of 10 divided by n to the power of 6, and that would equal n to the power of 4.
That's it. I can multiply and divide indices.
Tick.
This one, using your index rules, let me just change that to an x squared cubed. That is the same as x squared times x squared times x squared. Using your rule of indices, what would that be?
Would it be x to the power of 6?
Yeah. And so if we go back to the original question, What is the quick way of going from having 2 and 3 to just 6?
Add.
To 2 plus 3 is 6?
Oh, times together, sorry.
Yes. So to multiply indices, add the powers. To divide indices, subtract the powers. And then index to a power, you multiply the powers.
Okay.
So what is A?
Would that be 2 to the power of 12?
Yeah. B.
6 to the power of 10?
C.
4 to the power of minus 6?
And D.
And 5 to the power of 12.
Well done. This one?
Would it be x to the power of 6?
Yeah. Okay. Let's say bottom left.
Would it be x to the power of 15?
Top middle.
H to the power of minus 6?
And top right.
X to the power of 6.
Well done. I can raise indices to a power.
Tick.
Okay, how about this one? 2r squared cubed.
So, would it be 2r to the power of 9?
How did you get 9?
So, because these two r's times in 2 and 3 together, so that got 6. I left the 2 to the power of 3 alone, and that just left 2 to the power of 3 and r to the power of 6, so I added them together.
So this basically means 2r squared times 2r squared times 2r squared. So you correctly said it's r to the 6 and the number in front?
Is it 2? Or is it, oh no, is it 8?
Yes. And so it's basically the r squared cubed and the 2 cubed as well.
Okay.
So it's in a bracket, so it's the index is to both of them. So it'll be part A.
Would that be 10x to the power of 2?
And 5 squared isn't 10?
Oh, 25.
Yes. How about next one?
Would it be 16a to the power of 4?
Well, not to the 4. This was originally a to the 3.
Oh, was it? 12 to the power of 12.
Yep. Bottom.
So would it be 9 to the power of p q? Would it be 3p to the power of 10 and q to the power of 8?
Got it. So top left.
So would that be 27x to the power of 5?
What's the rule?
Times together, so 6.
Yes. And top right.
Would that be 8x to the power of 18, and then y to the power of minus 3?
Well done. I can raise indices with 2 and 3 terms to a power.
A tick.
What is a to the 6 divided by a to the 6?
Is it just a?
Well, what is 6 minus 6?
0.
And so it's a to the 0.
Okay.
What do you know about any number divided by itself?
It's a prime. Isn't it prime? Prime factor.
No. Any number divided by itself? 7 divided by 7?
Equals 1.
Yep. So any number divided by itself is 1,
Okay.
and any index divided by itself would be that to the 0. So basically any number to the power of 0 is equal to 1.
Okay.
Because it must have been divided by itself. So 3 to the 0?
Would it just be 3? Oh no, 1. Sorry.
5 to the 0?
1.
M to the 0?
No, 1. Sorry.
I'm right.
Is that just 1 as well?
Yep. I can raise indices to the power of 0.
Yeah, tick.
We don't need this. That's higher. Don't need that. There's only one more thing we need, and it's this one. Okay, what is the first one?
Will it be 25?
Yes. And then using your index rules, what's the second one?
So 25 to the power of 0.5. Would it be, is a simplified, would it be 25 to the power of 0.5 instead of half? Would that be the same?
Same thing.
Okay, so would it be 24 to the power of 1?
Yeah. What do you notice about the two answers?
The same. It's
Yeah. So something times itself gives you 25. Something else times itself also gives you 25. So that tells you those two must be the same thing. Anything to the power of a half means square root. So what is 16 to the power of a half?
Sorry, say that again?
So to the power of a half means square root. So what is 16 to the power of a half?
Is it still 16?
No. What does to the power of a half mean?
0.5. So would it be...
No. To the power of a half.
Oh, so would it be 4?
Yes, well done. Square root of 16. Don't need that. Okay, how about 11a?
11A. So would that be 6?
B?
9.
And I think that's okay. Let me just do a little thing. The to the power of a third means the cube root.
Okay.
Using something similar. And so what would be no, there's nothing really there, is there? What would be minus 8 to the power of a third?
Would it be minus 2?
Yeah. And so let's try these two.
Would that be 3?
Yeah.
And would the next one be would it be 3 as well?
Yeah. I can raise indices to a fractional power.
Tick.
And then you need nothing else from there. And so mixed questions. Okay, first one.
Would that be t to the power of 5?
Yeah. Next one.
Would it be 3a to the power of 4
Close.
minus 4?
Mm-hmm.
And then f to the power of 6?
Yeah.
Would that just be 1?
Yeah. Skip that. This one.
Would it be x to the power of 12?
Yeah. Next.
Would that be 10a to the power of 5 would b to the power of 4?
Yeah. This one.
So to start off, it would be n to the power of 10 divided by n to the power of 6. That would equal n to the power of 4.
Yeah. This little one.
Would it be b
Mm-hmm.
to the power of 14?
And this one.
Would it be n to the power of minus 10?
Under it.
Would it be 3x?
Not, not
power.
3.
Sorry.
Not 3.
Would it be 27?
Yeah.
27x to the power of 5.
No.
Oh, 20, I'm not sure.
Index to a power.
index to the power, would that just be times?
Yep.
Be 6.
Hmm.
And then y to the power of 12.
And this one.
Oh, will it be 4?
Yes. And let's see. So fine. What is this one?
Is it x to the power of 6?
And the one under it.
Is it 27 to the power of x to the power of 6?
And this one.
3.
Well done. So, indices in general.
Tick.
That's it. Yes. So that's indices anyway. How was that for you, Noah?
Yeah, that's alright. Cheers.
So we did vectors and indices. Is there anything in particular you want to do next, or should I pick?
I'll try and find something for next session.
Okay. Any questions for me in general?
No.
Okay. Well done, Noah. You did great. I look forward to talking again next time.
Me too. See you in a